Welcome back again. This is going to be episode number 40 of Learning by Doing MPI and part number 3 of basically MPI environmental management, which is the subject of chapter 9 of MPI standard. So, a previous episode, we basically talked about this error handling, but we haven't had time to basically take a look at the code and sort of the functions for this section. So, we're going to continue from here. We have MPI come create error handler. So this is that XXX we were talking about. So we remember that we had it for 4 types: for communicators, for files, for sessions, and for windows. So the first set of sort of functions are for communicators. And what this one does is basically creates an error handler. You see that gets an input, and that's a come error handler function. So this is sort of the error handler function, the callback function for the error handler. So that's a user-defined error handling procedure. That's a function. And you see that it has this very strange type. And we have seen these sort of strange types already. I think this, if you search for fn, we should be able to see that. So I'm at the general directory. So if I say grep -r, let's go with fn. Yeah, so you do remember again in the chapter for groups, contexts, and communicators and caching and MPI, when we were talking about those, caching capabilities in MPI, when you wanted to, for example, have copy copy callback functions, or delete callback functions, So you remember from that chapter these sort of very strange types that you see right here. For example, this is MPI come error handler function star. Okay. And then you see that what's going to get populated here is the error handler. So that is a MPI error handler. And you see the type is also MPI error handler star. So you see this is a pointer. What it does is that it creates an error handler that can be attached to communicators. The user routine should be in C, a function of type MPI come error handler function, which is defined as this. Sort of this is the signature of that function. It gets a communicator. Whoops, what was that? Gets a communicator and gets an error code, and you see that we have 3 dots here. So what is that? We're going to see it in a second. The first argument is the communicator in use. The second is the error code to be returned by the MPI routine that raised the error. If the routine would have returned MPI error in status, it is the error code returned in the status for the request that caused the error handler to be invoked. So this MPI error in status can happen in scenarios, for example, when you have multiple request handles, like with MPI wait all, those stuff that you might have multiple sort of request handles. And the remaining arguments are var args. So this is a variable number of arguments. So that you put these 3 dots here, whose number and meaning is implementation dependent. And implementation should clearly document these arguments. Okay, we do have an example for this one. This is MPI error handlers.c. Well, actually, I'm not in the same directory as before, so let's clear this. MPI, what was the name? Error handlers. So this is the example, and it's a very short example, but since there is sort of different functions here, before diving into this, I'm going to continue to see a bunch of other things related to communicators. So this was the first one, to create an error handler which could be attached to communicators. So you have this MPI come create error handler. The next one on the line is MPI come set error handler. So when you create an error handler, it's not automatically attached to the communicator. So you gotta attach it to a communicator, and that is this set error handler function. So you see that we have in out the communicator. So it can be an input, and behind the scenes, it goes to that structure, to that communicator structure, does some changes to that in the way that that error handler is getting attached to that communicator now. And then you see that this is also the error handler as an input, the new error handler for communicator. So you got to pass in your communicator, and you got to pass in the error handler that you created. Okay, it attaches a new error handler to a communicator. The error handler must be either a predefined error handler, which we already talked about it, like those 3 examples, which we had MPI errors are fatal, or or errors return, and those things. or an error handler that is created by a call to MPI come create error handler. Okay. The next one on the line is MPI come. So these are very self-explanatory, right? Set is to set the error handler to a communicator, and then MPI come get error handler. This is simply to you got to pass in your communicator, you got to pass in error handler. This is in a handle, and then it's going to be get populated with the error handler, which is attached to that. So this is error handler currently associated with communicator, and retrieves the error handler currently associated with a communicator. For example, a library function may register its entry point to the current error handler for a communicator, set its own private error handler for this communicator, and restore before exiting the previous error handler. Okay, and then I put an X here because the rest of this stuff is sort of the cousins of the same functions, but for Windows, for files, and for sessions. But since we haven't sort of dealt with those chapters yet, there's no point discussing those stuff. So I put an X here, and I'm going to continue because so we're not going to talk about these stuff. So the next one is, for example, for sessions. You can see here we don't care about these stuff. And then up until the second X I put here. And then before diving into this example, the last thing we need to check, I think this is the last thing we need to check, and that is MPI error handler free. So you gotta, when you make garbage, you gotta clean it. You see that this is an in-out error handler. You gotta pass in your error handler to this free. And it marks the error handler associated with the error handler for deallocation and sets error handler to MPI error handler null. The error handler will be deallocated after all objects associated with it, either it's going to be a communicator, windows, or files, have been deallocated. Okay. No, that wasn't actually the last one. We have another one, MPI error string. And this one, it gets 3 arguments, error code. Of course, this is the error code returned by an MPI routine. And then it's going to get populated by a string and a result length. So this string is the text that corresponds to the error code. And then the result length is actually the length in printable format of the result returned in the string. So this one returns the error string associated with an error code or error class. The argument string must represent storage that is at least MPI maxed error string. We have already seen this pattern. Characters long, the number of characters actually written is returned actually in this result length. This function must always be thread safe as described in this chapter. I don't care about that. It is one of the few routines that may be called before MPI is initialized or after MPI is finalized. So before MPI init or after MPI finalized might be also called. So that's it. Up until this point, we have seen MPI error string, we have seen MPI error handler free, and other sort of MPI error handler things which are related for communicators. We haven't talked about the other forms. So this is the example. So here is the sort of the error handler callback function. We have the same pattern as sort of the type def we have seen in the standard. So it gets a communicator and it gets an error code and it has this variable arguments. So what it does is simply that we have the string with this MPI max error string, and then we have the result length, and we use this MPI error string. You see that we associate this one, this is the error code, and then that's the string, and then that's the result length. And then what we're going to do is that we're going to say, hey, custom error handler, this is the message we want to print, and then we put the string here. So the message associated, the string or the message associated to that error code is going to get printed, but it's going to get printed after we say something which we say here, which is a custom error handler. So this is our sort of error handler, custom error handler callback function. And in the main, it's very simple. We have the error handler. We make an object of that, and then we have this MPI come create error handler. We pass in this. We want to create an error handler, which could be attached to a communicator. And then, so you're going to pass in your error handler here. And then, of course, you're going to pass in your callback function as well. And then MPI come set error handler. We want to attach that error handler to a communicator. And in this case, we are attaching that to MPI come world. And then we simply want to do something dubious, and that is we put the error code here. that MPI com rank, and we usually pass in here MPI com world, right? But we're going to pass in MPI com null, which is an invalid communicator. And then we pass in the rank as well. So this is how we were sort of getting our rank, right? Normally we pass in, as I said, MPI com world, but here we want to intentionally pass in an invalid communicator to see that this error, how this error is getting printed. And finally, we need to also get rid of that error handler with MPI error handler free. So let's try to run this, MPI CC MPI error handlers, and let's try to run it. So we know that this is a faulty program, and you see that what gets printed is that custom error handler, and it says the message that it gets, it's invalid communicator, and it is of course a class for itself, invalid communicator. It's simply because that we passed in to this instead of a valid communicator like MPI com world, we passed in MPI com null. So this is the message or the string that we get from that error. And you see that basically we used 8 processes, and that is why we get should be 8 times, I suppose. 2, 4, 6, and 8. Yeah, every process basically complains with the same sort of error, that we have a null communicator. So very beautiful example, very simple example, few lines of code, but you see very simply the syntax and semantics of having your custom error handlers. So we're going to continue with the next section, which is error codes and classes. The error codes returned by MPI are left entirely to the implementation with the exception of MPI success. This is done to allow an implementation to provide as much information as possible in the error code for use with MPI error string. So that's basically the function call which retrieves that string with that specific error code or sort of error class number. All MPI function calls shall return MPI success if and only if the specification of that function has been fulfilled at the point of return. For multiple completion functions, if the function returns MPI error in status, again, I said this is, for example, for when you have, for example, multiple requests like MPI wait all, MPI wait some or stuff of that nature. The error code in each status object shall be set to MPI success if and only if the specification of that operation represented by the corresponding MPI request has been fulfilled at the point of return. So you see, when you have multiple request objects, it's going to return MPI success only and only if that specifications are fulfilled for that specific MPI request object. Okay, when an operation raises an error, it may not satisfy its specification. For example, a synchronizing operation may not have synchronized, and the content of the output buffers, targeted memory, or output parameters is undefined. However, a valid error code shall always be set when an operation raises an error, whether in the return value. It can have different forms. It can be a return value that is being basically returned, or it can be error field in the status object, or it can be element in an array of error codes. So it can have different shapes and forms, but it always needs to basically raise an error for that. To make it possible for an application to interpret an error code, the routine MPI error class converts any error code into one of a small set of standard error codes called error classes. Valid error classes are shown in table 9.1 and table 9.2, so we're going to see it in a second. Or let me show it actually right now. So we have MPI. So these are the predefined error classes that we have. You see that on top we have MPI success, that no error has happened. And then you can take a look at this sort of, for example, the error that we sort of faced, that was MPI error com, invalid communicator argument. This is what we basically saw earlier here. Invalid communicator. So here also invalid communicator argument. And we have all sorts of different sort of errors. So they put it in 2 tables here. And the interesting thing is, for example, this MPI error other and MPI, I think, error unknown. So I think the next paragraph basically describes what's the difference between the two. Let's see. So the error classes are a subset of error codes, and an MPI function may return an error class number, and a function MPI error string can be used to compute the error string associated with an error class. The values defined for MPI error classes are valid MPI error codes. The error codes satisfy this condition. So the error codes have this form. They start from 0, which is MPI success, that the case that no error has happened, and whatever error which is happening. So whatever you see that in those tables, which are the predefined ones or the standard ones. So MPI error, whatever, has to have a number greater than 0, and it has to be less than MPI error last code. So this is the last code basically, which is being used for those standard errors that are defined. And then the rest of this stuff, which are going to be defined by the user, are going to have different sort of codes. And we're going to see that what's the difference between them in a second. The difference between MPI error unknown and MPI error other is that this is the paragraph what I was talking about. This is the rationale, is that MPI error string can return useful information about MPI error other. So this is the main difference between unknown, which is an unknown error, and MPI error other, which could return some useful information with this MPI error string. Note that MPI success equals 0 is necessary to be consistent with C practice. The separation of error class and error codes allow us to define error classes this way. Having a known last code is also a nice sanity check. Okay, then we have an example for this one, MPI error classes. MPI error classes. Before diving into that, you see that again we have this sort of error handler callback function, and this example is also very, very simple. But before diving into that, let's take a look at this. We have MPI error class. You're going to pass in your error code. This is error code returned by an MPI routine, and then what it does is going to populate the class for you, error class associated with that error code. So it's going to basically dump out the error class associated with that error code you passed in as an input. So the function MPI error class maps each standard error code or class onto itself. This function must always be thread safe as defined in this section. We don't care about that. It is one of the few routines that may be also called before MPI is initialized, or before MPI init and after is finalized, or after MPI finalized. So this is the table. We don't care about that. I think there is still, do we have still some other stuff which are associated with that? Nope, that's all. So let's jump into this example. So this is the sort of the callback error handler function. Again, we have the string, we have the result length. The simple change here we made is to add this error class, and then we have this MPI error class call, basically passing the error code that we have, and then associate that with an error class, which is going to get populated by this function, and then use this MPI error string to basically get the string associated or corresponding to that specific error code. And then what we're going to do before printing that error, we're going to print the error class before that. So we're going to print the error class that we got with the help of this MPI error class, and then we're going to do this custom error handler message again. And we're going to do the same dubious error again. So everything here is the same as the example before. So I'm not going to basically comment on that. So we're doing a very stupid mistake of passing MPI com null to somewhere which we shouldn't actually do that. We're not supposed to do that. MPI error classes, I'm going to compile that and run it. And this time, the difference of this example is that you see that the error class is actually 5. So we are printing the error class, which is corresponding to the error code that we are getting, and that error code corresponds to an invalid communicator. So you see that we have classes and error codes. So classes basically gives you a general category of errors which are happening, or a general domain that those errors are happening. And then you can have like a specializations for every category with the help of different error codes. So like you can have, I don't know, error code, 16, 25, 31, and then that is for one thing, and 16, 25, 30, 6, and that is for another sort of type of error, which you can distinguish them or specialize them with different error codes. So this is how you can do it. And then the next section, so again, that was a very simple example to basically showcase the syntax and semantics. And the next section is error classes, error codes, and error handlers. Users may want to write a layered library on top of an existing MPI implementation, and this library may have its own set of error codes and classes. An example of such a library is an IO library based on MPI. You can see it in chapter 14, which we haven't discussed about parallel IO yet. Okay, maybe we can speak. We can skip, not speak, but we can skip this portion. You can read it if you're interested. But this is basically the general procedure. You know, the functions are needed to. These are the requirements. The next section is user-defined error classes and codes. The procedure that add and remove error classes, codes, or strings are thread-safe, as defined in section 11.6. There are some of the few MPI procedures that may be called before MPI is initialized or after MPI is finalized. So before MPI init or after MPI finalized. We don't care about this advice to users. And then the next thing is this is probably the last example I have. No, the one before the last example. This is MPI user-defined error classes. So MPI user-defined error classes. So this is lengthier compared to the others. The others were simpler than this. But let's take a look at this. The first one on the line is MPI add error class. If you want to have a custom error class added to your program. So of course this is the output you get. So you're going to pass in this argument error class, and it's going to get populated with this MPI add error class. So this is the value for the new error class. And you see the type is actually an int star here. Creates a new error class and returns the value for it. To avoid conflicts with existing error codes and classes, the value is set by the implementation and not by the user, of course. And then advice to users, since a quality MPI add error class is local, the same error class may not be returned on all MPI processes that makes this call. This is very, very important. Thus, it is not safe to assume that registering a new error on a set of processes at the same time will yield the same basically error class on all MPI processes. This is not the case. Getting the same error on multiple processes may not cause the same value of error code to be generated. This is very important advice. The value of MPI error last code, this we already talked about before. The value of MPI error last code is a constant. So I sort of see an inconsistency in the standard. They should have defined this MPI error last code earlier when they talk this sort of logical numbering, or when they talked about this thing. I think they should have already mentioned what is this MPI error last code. But you see the description is basically postponed up until here. You see the value of error last code, MPI error last code, is a constant value and is not affected by new user-defined error codes and classes. So MPI error last code is basically whatever standard errors that we have. It's not going to change. And if you add some error codes or error classes, it's not going to affect this last code. What's going to affect is actually the last used code. Instead, when using the world model, a predefined attribute key MPI last used code is associated with MPI com world. The attribute value corresponding to this key is the current maximum error class, including the user-defined ones. So this one, if you change the error codes and classes, it's just going to reflect into this MPI last used code, but not in MPI error last code. This is a local value and may be different on different processes. This is also a very important thing to know. The value returned by this key is always greater than, So I think we're going to continue in the next episode. I'm not going to finish this. Okay. I'm going to see you in the next one.